This module incorporates 4 different operations. All 4 operations use the climb page, which is displayed. Let's look at the first operation, flying speed restriction. In this situation, you are at the gate and need to set the initial flying profile of 210 knots until reaching 2,500 feet above field elevation. To add these parameters to the climb page, enter the speed and altitude into the scratch pad, then select the speed restriction line. Note altitudes are automatically rounded to the nearest 10 feet. When the entry is executed, the active page title will reflect the new speed restriction. After climbing through the restricted altitude, the speed restriction line will display dashes, and the page title will change to the default climb mode. There are 2 default climb modes, 250 knots below 10,000 feet and economy climb from 10,000 feet to cruise altitude. Now let's do an exercise. Let's now look at the climb speed delete operation. In this situation, you will depart over coastal water, which does not require the 250 knot restriction below 10,000 feet. To remove the restriction, press the delete key and then select the speed transition line. When executed, the climb page title will change to economy climb and the speed transition line will be blank. Now let's do another exercise. The next operation is a climb speed change. In this situation, ATC directs you to maintain 250 knots until further advised. To satisfy the clearance, enter the restricted airspeed in the scratch pad, then select it into the economy speed line, which will change to selected speed. When executed, the active title will indicate the entered speed. To return to a normal climb speed, line select the economy flying prompt and execute the modification. Now let's try a couple of exercises. Let's now look at the last operation, climb direct. In this situation, ATC cancels the crossing restriction at North 2 and clears you to climb direct to your MCP altitude. A direct climb can be commanded by line selecting the Climb Direct prompt. Once executed, all waypoint constraints between the current altitude and the MCP altitude are deleted. However, the aircraft is still limited by the speed profiles entered on the left side of the climb page. Let's try a final exercise. In this situation, ATC has directed you to maintain 250 knots due to heavy traffic. This calls for a temporary speed restriction and is accomplished by using the speed intervention function. Speed intervention can only be used when VNAV is engaged. To use the speed intervention method, first press the IAS Mach selector switch. The blank IAS Mach window will now show the current airspeed. Next, dial in the new airspeed, which will be maintained by the autoflight system. The VNAV altitude profile will remain engaged. To revert to the FMC target speed, push the IAS Mach selector switch again. The blank IAS Mach window will now show the current airspeed. In this situation, ATC has directed you to maintain 12,000 feet until further advised. This calls for a temporary altitude restriction and is accomplished by using the MCP. To satisfy a temporary altitude restriction with VNAV engaged, dial in a restriction in the altitude window. When the restricting altitude is reached, the VNAV mode will disengage and the altitude hold and speed mode enunciations will be displayed on the ADI. To resume the desired climb or descent, dial the new altitude in the window. Then press the VNAV switch and verify that the VNAV mode has engaged. In this situation, ATC has directed you to cross North 2 at 15,000 feet. This is accomplished by adding the constraint to the waypoint on the legs page. Airspeeds and altitudes displayed in large characters are constraints, and the small characters are estimates. The constraints may be entered manually by the crew or automatically as part of a procedure. A valid entry for an altitude constraint is 3 to 5 characters. 3 numeric characters will be considered a flight level at or above the transition altitude, or hundreds of feet below the transition altitude. Flight level altitudes may also be entered with an FL preceding the 3 numeric characters. The constraint is then line selected into the appropriate altitude line and executed. And finally, verify that the autopilot is still in the VNAV mode. If the constraint is to cross at or below an altitude, enter the letter B after the altitude. If the constraint is to cross at or above an altitude, enter an A after the altitude. When the constraint is entered and executed, the constraint altitude will be followed by the above or below restriction. If the constraint involves two altitudes, enter the lower altitude followed by an A, then enter the upper altitude followed by a B. When this line is selected and executed, the altitude line will show the lower limit followed by the upper limit. A valid Mach speed constraint is a decimal point with 1, 2, or 3 digits, followed by a slash mark. A valid airspeed constraint is 3 digits, followed by a slash mark. The speed constraint must be followed by an altitude constraint, unless one has already been entered. When the speed constraint is line selected and executed, the altitude line will display both constraints. Let's now try a few questions. In this situation, you are at your cruise altitude when you encounter an unforecasted headwind, which could cause the flight to arrive late at your destination. To arrive on time, you decide to increase your cruise speed. To do this, enter the new speed in the scratch pad, then line select the economy speed line. When executed, the page title reflects the new cruise speed. To return to economy cruise, select the economy prompt. Then execute the change. Now let's do an exercise. In this situation, you are at your cruise altitude when ATC advises you of turbulence ahead and clears you to flight level 370. To accomplish a cruise altitude change, first set the new cruise altitude on the MCP. Notice that the new altitude is also displayed in the scratch pad. The new altitude appears in the scratch pad if it is between 43,000 feet sea level and 4,000 feet below your present altitude. Next, enter the new altitude into the cruise altitude line. When executed, the page title will change to Cruise Climb, and the aircraft will begin its climb. Let's do another exercise. In this situation, you are slightly southwest of Volunteer, preparing for your descent into Cincinnati. In preparation for descent, you must establish an accurate top of descent point, or TD, for proper VNAV operation. To accomplish this, you must first create an end of descent point, or ED. The end of descent point can be created by making an entry on either the arrivals page or on the legs page. Let's first use the arrivals page. Let's assume that you select the Swede 2 star volunteer transition and the ILS to runway 36 left approach Zerke transition. After you verify and execute the route, the FMC will automatically compare all new waypoint restrictions and define the end of descent as the lowest waypoint or position with an altitude constraint. In this example, the end of descent point is the glide slope intercept to runway 36 left. Once the end of descent point is established, the FMS constructs a VNAV descent path from the end of descent over the other constrained waypoints up to the cruise altitude. This establishes an initial top of descent point. The VNAV descent path assumes an initial optimum descent at idle thrust, using an economy speed schedule to the first constrained waypoint, Falmouth in this case, which has an airspeed and altitude constraint. Beyond this point, the VNAV path complies with all other waypoint airspeed and altitude restrictions to the end of descent point. A deceleration segment is also included to slow the aircraft to 240 knots below 10,000 feet. By selecting the descent page, you may verify the end of descent point on the CDU. This page also displays the first waypoint altitude constraint on descent and the FMS economy descent Mach and speed. Additionally, the page indicates the FMS speed transition, which is automatically linked to the destination and matches the deceleration segment on the HSI. Let's now create an end of descent point using the legs page. Assume that ATC clears you for a visual approach to runway 09, crossing Falmouth at 250 knots, 12,000 feet, and Cincinnati VOR at 5,000 feet. To create the end of descent, enter the altitude constraint in at least one of the descent waypoints. In this case, when two restrictions are entered, the FMC selects the lowest constraint, Cincinnati VOR, as the end of descent point. The FMC then constructs the VNAV path and establishes an initial top of descent point, which is based on the first descent constraint. If there are no altitude constraints for descent, you can manually construct an end of descent waypoint on the legs page. To do this, select a waypoint approximately 30 nautical miles from the destination, Falmouth in this case. If there is not a waypoint at this range, then modify an on-track waypoint to create one at 30 miles. Then enter a 250 knot, 10,000 foot. The FMC now has an altitude-constrained waypoint to define as the end of descent point, and will create a descent path and the initial top of descent point. If the descent page is blank, this indicates that no defined altitude constraint below cruise has been entered. Consequently, the FMC cannot identify an end descent point. To correct the page, you must recheck your descent routing and make an appropriate entry on the arrivals page, or the legs page. In this example, a restriction is manually constructed at Falmouth so that the FMC can identify an end of descent and create an initial top of descent point. After creating an initial top of descent point, you should then refine this point by entering all appropriate data on the descent and descent forecasts pages. Since the descent page is set up automatically by the FMC, it normally requires only verification and no new entries. However, if appropriate, the economy airspeed may be changed to a selected speed, or a speed restriction may be entered as directed by ATC. When any entry is executed, the top of descent point will be readjusted slightly by the FMC to reflect the new data, which will be displayed on the HSI. The Descent Forecasts page allows you to refine the top of descent point for icing conditions and winds at altitude. First, enter the altitude where thermal anti-icing will be turned on. In this example, 14,000 feet. Then enter the altitude and en route wind. In this case, flight level 330 and a wind from 270 degrees at 39 knots. Based on this data, the top of descent point will then be readjusted by the FMC to permit a more efficient VNAV descent path. By referring to the cruise page, you may check the time and distance to the readjusted top of descent point established by the FMC. Also, by selecting the progress page, the same information is available. Now try a final exercise and a couple of questions. In this situation, you are south of Swede and have been cleared for descent into Cincinnati. To allow for a smooth intercept of the VNAV descent path, you should initiate the descent approximately 15 nautical miles prior to the top of descent point. To accomplish this, first set your descent clearance altitude in the MCP altitude window. Next, when the aircraft is 15 nautical miles from the top of descent point, select the descent page and press the Descend Now prompt. When executed, the aircraft will begin a 1,000 to 1,500 feet per minute rate descent at descent speed until intercepting the VNAV path. When the descent begins, the descent page becomes active. Also, a path error line appears, which displays altitude and distance discrepancies to the VNAV path. When the VNAV descent path is captured, the pitch mode changes from VNAV speed to VNAV path, and the auto throttles go to idle. Normally, the economy descent speed is maintained until reaching either the first constrained waypoint or the speed transition altitude, whichever occurs first. If a descent speed change is necessary, a selected speed may be flown while maintaining the VNAV path. To accomplish this, first enter the new speed on the Econ speed line. When executed, the tidal and speed line will change to the selected speed, and the auto throttles go to speed. Also, an Econ prompt will be displayed for reselecting the Econ speed schedule. Another option on the active descent page is Descent Direct. When selected and executed, all waypoint constraints between the current altitude and the MCP altitude are deleted. The airplane will begin an unrestricted descent to the MCP altitude at the FMS descent speed, complying only with the deceleration segment at the speed transition altitude. In addition, the waypoint constraint line will display the next constrained waypoint after the MCP altitude.